Welcome to Maze Leetcode Challenge. Today's problem is construct binary search tree from Preorder Traversal. So return the root node of a binary search tree that matches the given Preorder Traversal. If we recall, Preorder Traversal simply means traveling to the left node, right node, then the node itself. And we know that this is a binary search tree, so we'll have to use the values given to us as the logic to determine if we want to go left or right. Say we're given this example, 8, 5, 1, 7, 10, 12. As long as, let's start at the beginning. If the numbers are decreasing, 8, 5, 1, we know that's always going to get added to the left node, right? So we have our node and we add it to the left. Then we could use that node to know if the number decreases, we're going to add a node to the left side of that node, and so on and so forth. It's only when the number increases that now we need to add to the right side. But which node do we add it to? Because we simply move up and say, okay, add to the previous node before this, the 7, that's actually not always going to be correct. It's totally possible that this number is actually the right of here. Let's say there was no 7, it was a 10. We need to know, okay, we should call back all the way up to 8 first and forget about 5. Like, that tree's done. So what sort of data structure would come in handy for this? A stack would be great, right? Because using a stack, we could build it up, and then once we fill up the left sides, pop them off until we know which right side to add it to, and continue on with the algorithm. So I'll start coding it out, and hopefully it starts to make sense. First, let's just build our stack here, and let's also get the length of the preorder list. So this is just a list of integers, and we're going to traverse through that just using the n. And finally, let's first build our root, right? We want to say, what's our root? It's going to be a tree node of preorder, the first value there. So is that right? Preorder dot 0, and we want to get, yeah, so that's going to be value in that preorder list. That'll be the root node. Next, we'll add the root to our stack. So let's add that to our stack. And here's what we'll do. We're going to traverse through our preorder list. We'll say for I in range of 1 through n. And we're doing that because we've already added the first one, right? That's our root. So we don't want to add that again. So we'll start at 1. And there's basically two conditions, right? If this value is less than the current node, then we're going to add it to the left. Otherwise, we're going to add it to the right. But the trick is which right. And luckily, we have this stack to be able to tell us pop off stack to know which one. All right, so let's start with here. We'll say, okay, if our value, and we could just simply use the -1 index to say that's the last, the latest one on top of our stack, and say, okay, if this value, right, or let's say preorder I, if it's less than this latest stack's current value, then we're going to add it to the left, right? And we know that. So let's take our stack dot -1. That's going to be a tree node, and we'll add to its left a tree node. And don't want to miss these typos of the value currently that we're in. So preorder I. Great. But that's not enough. We need to add it to the stack now because we don't want to continue adding to the same one. We just added to the left. So we'll add this one to our stack and continue on our algorithm. So we can just pick this left that we just created. We don't want to create another tree node. So there. Now, else the decreasing order has ended, and we want to add to the right? So which one? And that's where we'll have to create a while loop and say, okay, if there's a stack, and the stack, the top one's value is not, let's do it this way. If the preorder I is greater, this is current stock value I like this, let's pop them off and store the last one that we just popped off. So we say, so this is the last one. So that way, once we hit this condition where, all right, we know that, let's say, that's not an example, but let's say the value is finally no longer greater than the stack value. So that previous one that we just popped off, that's the one we're going to add a right to. So let's get to our right, and we'll say, okay, we know that this is a tree node, so we'll get the right and create a tree node here. And finally, add this, is that right? Add this to the stack. And I believe that's correct, yes. Stack.append, add that to the right here. And that should finish our loop. And once we're done with that, now we have our root. We stored it luckily, and that's going to have our binary tree that we built. So let's try running that and see if that passes first. Looks like our test case has worked, and let's submit that. There we go, accepted. So it's pretty straightforward, like coding it out like this. The trick, really the hard part to come up with is this stack formulation. If you can remember that though, it makes it a lot easier because we know this pre-order. If we went like post-order, it would be the same thing except we'd add the right first and then build a stack for the left or something like that. So, all right, thank you.